Hello and welcome back. So if you have been following along, on the previous session we talked a little bit history of SQL Server encryption, as well as we talked the components that are involved in the process of encryption for SQL Server Engine. So what we're going to do in here today is we're going to go ahead and configure cell or column level encryption. So if you're looking to this table right here, all of these columns, you should be able to notice that there is one column that's containing some of the sensitive data, and that is the card number. So our intention in here is to encrypt this column in order to prevent those people who has access as read access at database level, and we want them not to see this sensitive information because this is our customers credit card, debit cards, numbers, and we don't want anybody to look at this other than the people who are actually authorized. So for that reason, we're going to go ahead and configure cell or column level encryption. And the first thing we need in here is we have to use the same database that we have a table to encrypt a column of it. Then let's go ahead and I have a table called in here credit card. So the credit card has a column called card number. So if I select all from this table, uh, I should be able to see the same column. I showed it before right here. So we want to encrypt this column. So what we're going to do first thing in here is we're going to go ahead and create a symmetric key. So a symmetric key is pretty much, let me bring up this PowerPoint. So it is the same key that can be used to encrypt and decrypt data. So when we are sending data or writing data to the database, it encrypts it. And when we are asking for a data or requesting data from database, it is going to go ahead and decrypt data for us. So pretty much this is a single key that can be used to encrypt and decrypt data. Okay. So let me go back to the SSMS. So the syntax that you are supposed to encrypt data is pretty simple. You just say create and create what? Symmetric key, then provide it a name, and then with algorithm. And this is pretty much a strong algorithm that SQL Server can offer. So I use 256. You have other options, 128. And then you encrypt it by a password. So make sure this password is very protected. It is very strong password, and do not share this password with anybody other than the people who are intended to decrypt data and are authorized to encrypt and see this column right here. Okay, so I will select them all, run them. So a key has been created. If you're wondering where the key will reside, so it is under the security. If you go to your database and then all the way down here, you have a security folder and then you have symmetric keys. So if I go and refresh, expand it, I do see the phone encrypt. The same key has been created. So the next thing in here is in order to use that key, we have to open the key. So the syntax for the open key is open symmetric key provided the name decryption by password, and you provide the same password. So people who intend to decrypt your data, they should know this password in order to decrypt it. So what I'm doing here is I'm going to go ahead and run it. So now the key is open, and then I'm going to go ahead and update a column within this uh, table. So if you look, I have different columns in here. As I mentioned, we're going to go ahead and encrypt card number. So if you're familiar with T-SQL, this is pretty much a simple update statement. So update table name set a column name equals. So I'm using a built-in function in here. So it requires a key guide, and then it requires the uh, symmetric key name in here. So if you look, the symmetric key phone number is actually written in here. So do not put a different key in here unless if your intention is to encrypt or decrypt it with that key and that key is open. So for now, I have phone encrypt key open in here, and then I'm going to use it in there. So what you're going to go ahead and encrypt, so provide the column name. Now, this function requires an authenticator, and what we're going to do in here is we provide one and then convert the authenticator to give us var binary data type and select a column that is unique within your table right here. So if you have a column that contains primary key, so no brainer, go ahead and select that column right here. If you have a table that doesn't has any primary key, so select the one that has unique numbers or unique values and that there is no duplication in it. So in my case, credit card ID is kind of unique, although it's not a primary, as you can see in there. So I'm going to use that. So I will go and select. Okay, so I do get an error in here. So if you are noticing this in here, so it says, let's see if I can bring it up. Uh, okay, so oops, too much. So right here it does says uh, a string or binary data would be truncated. So what that exactly means is that means that the card number right here, this card number, let's go a little bit expand this. If you look in here, the allowable character in this column is 25. So it says when we are trying to convert or encrypt this column, the number of character is 25, but when we are encrypting it, there are more character needed. So the number of character is exceeding 25. So this means we have to go and allow more characters in here in order to and the encryption data can fit in within this column. So what I'm going to do in here is in order to fix this, I'm going to go ahead and right click on the table, go to the design, and what you're going to do in here is you go find the column and let's go and make it 250. Close. Yes, the changes are taking effect and update. So now if you're encountering any problem while you are going to the design and when you make a changes and you close and then they ask for table recreation and it will not allowing you to make the changes. So what you're going to do in here is go to the tools, to the options, and find designer uh, right there. So this option should be unchecked right there. I already have it unchecked. So if you have it checked, make sure you uncheck it and then click OK and go ahead and bring the changes again and then you should be fine. Okay. So the key is right now open. We updated the columns. Now I'm going to go ahead and close the key. And let's go ahead and select data, see if it has been encrypted. Okay, so you see right now the data has been encrypted. So nobody actually can read this data. So the only people who are authorized to see this is the one who should know this password. So let's go ahead and decrypt this and see how it works. So in order to decrypt it again, we have to encrypt, we have to open the key. And then we're gonna go ahead, if you look in here, I can select many columns, but I opted to select card type and then card number, as this time it is encrypted. And I will give it an alias name for the card number as encrypted card number. So then I'm gonna go ahead and use the decrypt by key function. So if you notice in here, I did use encrypt by key function, and it is pretty much requiring the same parameter, the same authenticator. So I provide the card number, convert, var binary authenticator, but the value of this would be as decrypted card number. So we should have two columns, one encrypted number and the other decrypt number. And then from that table, and we're gonna go and run this. Okay, so now if you notice in here, I have encrypted format of that column as well as I have the decrypted version of that column. So these numbers has been decrypted and to uh, under the decrypted number. And if you notice in here, they are actually encrypted within the table. Now, if anybody, let me go ahead and close the key. So the key is now closed, nobody can use it. So now if somebody come in here and try to select data from that column, they can see everything, but not the card number. So make sure when you are, again, make sure when you are making this password or somebody directing you to give that password for the key, make sure you share this password with the authorized individuals only, because what they can do is they can actually use this built-in function key and decrypt your data. If they're not an authorized user, then the whole value of encryption will be gone. Okay, so make sure you keep this in a safe place and only share it with authorized users. So I guess that's it for today. We did configure cell or column level encryption. And what we did in here was we did create a symmetric key, and then we encrypted by this encrypted key function. Then we decrypted by a built-in decrypt function. Okay, so right now your table will be like this, and nobody actually can see it other than authorized user. So that's it for the column level encryption. And I will stop the video, and the next session I'm going to go ahead and talk about backup encryption. So I will see you on the next session.